Now, before we take our break, we'd like to give Jim Holstein a chance to do his presentation. We just have to back up a little bit in the back to the morning.
Is this the backup of shame?
This is your walk of shame to do your talk.
Yeah, sorry, I had a meteorite emergency this morning. They do happen.
Don't you hate it when that happens?
Uh-huh.
Tell me when to stop. If you see it when
that looks good. Oh, that's Adrian's. Never mind. One more.
Oh, there you are.
Fantastic.
Okay. Jim Holstein.
Thank you, everyone. Hi. How's everyone doing this morning? We'll get you to your coffee break shortly. We're going to talk about this very unimpressive looking rock, which is a meteorite rock from space. In 1969, September 28, 1969, a huge fireball was seen over Victoria, Australia. It exploded, raining thousands of pieces of this meteorite over a large area. This ended up being one of the most important scientific finds of the 20th century. This is a carbonaceous chondrite, which is a rare type of stony meteorite. And 100 kilograms were recovered during this fall, and the Field Museum has about 40 kilograms in our collection. It is our most widely requested meteorite loan request. This has spawned hundreds of papers because of its scientific importance. What makes it so interesting? It's a black rock. It looks like very boring. You see little specks in there. You see little chondrules, which makes it a carbonaceous chondrite. The chondrite refers to these little spherular inclusions called chondrules. These meteorites are considered primitive meteorites, in that its composition closely resembles that of the early photosphere of the sun. Does that make sense? 4.5 billion years ago, we were a big cloud of dust and gas. Material started to accrete to form solid objects. The earliest solid objects formed on these types of meteorites. Other types of planetary bodies would later evolve into differentiated bodies like you see on Earth or Mars, even the moon. This type of meteorite remains virtually unchanged from 4.5 billion years ago. The chemistry is very primitive, and it hasn't undergone all that much thermal alteration, which means it didn't grow to the size where it had internal heating. It didn't grow to the size where it started to differentiate, form a core, for example. So these meteorites contain about 66 different minerals. And the Earth today has about 4,500 minerals. Earth is a very geologically active planet. You have reworking materials, you have aqueous alteration, you have metamorphism, creating more minerals on Earth. This type of meteorite is unchanged. So it gives us a rare insight to the early processes of our solar system. So the other really interesting thing about this meteorite, it tells us about what happened before our solar system was formed. So the date of our solar system is 4.567 billion years. It's a nice number you can use at the next cocktail party. That number comes from the first solid materials to accrete on these meteorites. These materials are called calcium aluminum inclusions, and they have been age dated to 4.567 billion years. But these meteorites also contain materials that predate the formation of our sun. So in the 1960s, they started finding anomalous neon isotopes inside this meteorite. Isotopes that can only be formed during stellar processes, for example, like a supernova. And it wasn't until the mid-1980s when the University of Chicago, using Field Museum specimens, was able to isolate the carrier of these isotopic anomalies. And that was in the form of diamonds. And as you all know, diamonds are made up of carbon. And as you also may all know, diamonds are formed under extreme heat and pressure, and conditions that only occur either deep in the Earth's mantle or in supernova explosions. So since they discovered these diamonds, they discovered about a dozen or so pre-solar minerals that predate our solar system. So when people ask me, what's the oldest material we have at the Field Museum? Everyone's like, dinosaurs, ooh, invertebrate fossils. No, I say, no. I see Paul back there looking. I say, no, pre-solar grains, because they can predate our solar system by up to 1 billion years. So these meteorites, though very physically unimposing and unimpressive to look at, have some of the most important data that we can use scientifically. And I'm going to end it there because I want some coffee. So have a good day.
Okay, we'll have about a 5-minute break and we'll resume.